are with another lesson, this time in a new chapter where we're going to talk about measurement of figures. Today's lesson is on arc length and radians. So first we'll talk about circumference. Circumference is the distance around a circle. Love that. And for all circles, the ratio of the circumference to the diameter is the same, and that ratio is pi. If we solve for c, that gives us the formula. So pi is the circumference divided by the diameter. So if we solve that for the circumference, that gives us the circumference equals pi times the diameter. Since we already know that the diameter is twice the radius, you can rewrite that as c equals pi 2r, or as you'll often see it, 2 pi r. And you'll learn about why that's fun in calculus. Just something to look forward to. Here we'll find the indicated measures based on the given information. So we want to find the circumference of a circle with a radius of 9 centimeters. So that's going to be 2 pi r. So sometimes you'll see that left as 18 pi, but our directions tell us to round to the nearest 10. So I'll just multiply 18 times pi, and that's 56.5 centimeters, since units are important. Now we need to solve for a radius with a circumference of 26 meters. So 26 equals 2 pi r. Pi is a constant, so I can divide at the same time by 2 pi. So I'm doing that all in one step, and that leaves me with 26 divided by, nope. That makes more sense. So that gives me 4.1 meters. Make sure you put that in parentheses when you divide. All right, and now we're looking for the diameter if we have a circumference of 35 pi yards. So we'll have to solve for the radius first. So that's 35 pi equals 2 pi r. If I divide both sides by 2 pi, divide both sides by 2 pi, I get 17.5 equals r. And I know that the diameter is 2r, so that's 2 times 17.5, which is 35. And what do you know? That's, again, based on that ratio. So the diameter is 35 yards. All right, first part. Second part, arc length. Arc length is a portion of the circumference of a circle. So that's this part that we're talking about here. The measure of an arc is in degrees. So that's what we've done before. And the length of an arc is in units. Units of length. So that's like centimeters, meters, yards, etc. So the formula for arc length is going to be L equals 2 pi r, look familiar, times x, which is in degrees, divided by 360. So this is our circumference, and that's our angle. 360 is always going to stay the same because that's the total number of degrees in the circle. So let's use this formula to find the arc length of arc AB. So arc AB is right here. So we'll use the same formula, 2 pi r times that degree is 150 divided by 360. Oh, I should have put in the radius. So that's the radius, and that's the degree. So 2 pi 18 times 150 over 360. So you put it in your calculator just like that, especially if you're using a TI-84 or better, or Desmos. So 2 times pi times 18 times 150 divided by 360. Make sure you use parentheses, super, super important. Make sure that your answer makes sense. So that's 47 point, one around to the nearest 10, 0.1, and this is measured in inches. All right, same thing here. Here this looks like the diameter is 14 feet, so that then the radius is gonna be 14 feet. So we have 2 pi times 14 times 30 over 360. 2 pi times 14 times 30 over 360 gives us 7.3 feet. Yeah. Cool. Same thing here. We use the diagram of the circle. We'll rewrite the formula here, 2 pi r times x over 360. Use the diagram of circle D with angle EDF is congruent to angle FDG. So these are congruent. So find the indicated measure. All right, so if that's 80, this is also 80 degrees. So 360 minus 160, obviously, I should have done that, is 200 degrees. All right, so the arc length of major arc EFG. All right, so L equals 2 pi, the radius is 7, times EFG, that angle is going to be 160 over 360. So we have 14 pi divided by 160 over 360. Sorry, technical difficulties. 19, we can round to the nearest tenth again, since that's what the other directions have told us. 19.5 meters. Now the arc length of major arc FEG, so that's here. So it's all but 80, so it'll be 280. So the length is 2 pi, the radius is still 7, times now 280 over 360. Because I keep dividing, that's why I'm having this issue. 14 pi times 280 over 360. So that'll be 34.2 meters. That makes sense. We're traveling a further distance this time rather than a shorter distance with a smaller angle. So hopefully you see those differences there. All right, now we have a mixed bag with these four before we move on to radians. So find each indicated measure, round to the nearest tenth, and use units. So we want to find the circumference here. So if I know this arc length, I can solve for the radius. And then if I know the radius, I can find the circumference. So let's do that. So 4.19 equals 2 pi r times 40 over 360. So I can do 40 divided by 360 times 2 pi. So I get 4.19 equals 0.6981 r. Divide. Oh, guys, you don't even have to. You're doing too much. Look, that's. Let me just different color. That's the circumference. So I just have to divide by 40 divided by 360. Wow. Let it all make sense. So the circumference is 37.71 inches. Cool. All right, here, I guess this is my arc length. So 61.26 equals 2 pi r times 270 over 360. So I would divide both sides by 2 pi. That reduces to 3/4. So give me what r is. So that's 6/4, 3/2. So that's 3 pi over 2 that I'm really dividing by. So I have 61.26 divided by 3 pi over 2. It gives me 12.9999. So rounding to the nearest 10, that'll be 13. So the radius is 13 meters. This is so fun. A 16-inch pendulum swings through an angle of 40 degrees. How far does the tip of the pendulum travel in a single swing? So a 16-inch pendulum goes through 40 degrees, and we want to know how far it swings. That would be the length there. So the length is going to be 2 pi r times x over 360. Not bad, not bad. Alright, since that was a little bitty angle, that goes, so I did 2 times 16 to get 32, 32 pi times 40 over 360. That gave me 11.2 inches. So it didn't yet hit its radius of the swing. Let's see why that is later. A car entered a traffic circle, traveled 280 feet, and then turns. If the traffic circle has a diameter of 150 feet, find the angle of rotation to the nearest degree the car travels. So it has 150 feet, so that means a radius of 75 feet. And the car went 280 feet. So, I don't know, maybe that far, and turned off. We'll see. We'll use the arc length formula. L equals, oh no, we know L. So it traveled 280 feet, so that's L. So 280 equals 2 pi 75 times x over 360. So let's just get rid of that 360 first. So 360 times 280, 100,800 equals, that would be 150 pi times x. Now I'll divide by 150 pi. Divide by 150 pi gives me, it's to the nearest, so that's 213.9. And I want to know it's the nearest degree. So that's 214 degrees. Yeah, a little over 180 before 270. A little closer, but not bad. All right, radians. It's going to blow your minds, but sorry, I need a sip of water for this. This is another way to measure degrees. Is a unit of angle measure, duh, not degrees. Based on arc length, I guess. We'll see. 1 radian is defined as the measure of the angle formed when the radius is equivalent to the length of the intercepted arc. So this is the radius. This is the radius. This is the arc length when the arc length equals the radius. So the radian is going to be that angle here. So it's what x equals when the arc length equals the radius. So 2 radians is going to be, if these are both radii, and that's a radius and a radius. So maybe it equals, L equals the diameter. And then this would be 3. We're almost halfway to the circle. And we look here, well, you notice there's a semicircle there. And that's pi radians. Yo, isn't math cool? No, it's stupid. I hate you. Okay. Let's apply this. Fun fact. You'll learn more about this in pre-calc, and then you'll use it in, you guessed it, calculus. So many fun things for you to learn ahead. So looking here, again, radians is an angle measure. So radians is equal to the number of degrees times pi radians over 180. Same thing here, except just the inverse. And then this is how we convert between degrees and radians and degrees. So let's practice a few. Excuse me. So I'm going to convert each angle measure to radians. Radians will be helpful when you take physics and calculus. People don't really worry about degrees anymore. So that's why we're introducing it to you now. So I have 60 degrees, and I want to get that from degrees to radians. So I'm going to use this first one. So I'm going to take 60 degrees, multiply that by, I fix it on the handout, but it's wrong here. So it's right on yours, wrong on mine. And that's my bad. Sorry, Mrs. Gonzalez, don't be mad. So I'm going to multiply this by pi over 180 degrees. And I'm going to leave it like that for now. I'm just going to multiply straight across. So that's 60 pi over 180. Those degrees are going to eliminate. And then I can just reduce that fraction. So that 6 over 18, I know, is just 1 over 3. So this reduces to pi over 3. Done. That's it. Here we have 160 degrees. So I'm going to multiply by pi over 180 degrees. So I have 160 pi over 180. So those degrees canceled or eliminated, those zeros eliminate. And now I just reduce the fraction part. I know I'm going to leave the pi in the numerator. So that's going to be 8 pi over 9. That's almost 1 pi, remember? This is going to be pi radians when it goes all the way here. So 8/9 pi would maybe be around here. 330 times pi over 180 equals 330 pi over 180. I'll just reduce that fraction. And that's 11 pi over 6. I'm leaving it just like that. I'm leaving it an improper fraction with pi in the numerator. Same thing, 45 times pi over 180. Reduce those fractions. I know that this is pi over 4. 230 times pi over 180. Reduce the fraction, 23 over 18. Doesn't reduce, so that's fine. You just leave it like that, 23 pi over 18. Notice all of these have pi in the answer. $75 degrees. 75 degrees times pi over 180 degrees. That's going to be 5 pi over 12. All right, and then here, convert each angle measure to degrees. So we're just going to multiply by the reciprocal now. So I have 5 pi times 18. I want to get rid of the pi. So I'm going to multiply by 180 over pi. My goal is to have those pi's to eliminate. If I can cross simplify, I will. Like that's easy for me to see. 18 goes into 180. And then this one I can do in my head. 5 times 10 is 50 degrees. So I'm always multiplying with pi in the denominator now so I can get rid of the pi's. That's also an easy one to do in my head. To eliminate, I'm so embarrassed, I just didn't the calculator, pretend you didn't hear that. So that'll be 220 degrees. So again, 180 over pi. That should have been that. That's 60. 60 times 7 is 420. And that's greater than 360, so that means that we know we go around, sorry, let me start. So we would start here, that's 360, and then another 60 degrees, so that would be 420 degrees. And that makes sense because that's more than, this would be pi, and that would be 2 pi, so 7 pi over 3 is more than 2 pi, we're going around more than 2 pi times. I know, really interesting. Crossing out the pies, cross out the pies. Nope, no, this is the person. 30 degrees. It's a good one to memorize when you're in pre-calc. All right. This one, not going to reduce in my head. I'll just multiply. So that would be 19 times 180 divided by 12. 19 times 180 divided by 12. I just need to make some more. 285 degrees. And 3 pi over 4. 180 over pi. That's going to be 270 degrees. So when you're a math teacher, you have to memorize some of them. All right, so we want to eliminate pi when converting to degrees, and we want to keep pi in the numerator with an improper fraction when we convert to radians. All right, last page we'll do together. So arc length, you may be saying, wait, didn't I do this already? You did with degrees. Now we'll do this with radians, which may make it easier. So if you have theta, again, that's theta, you draw it like a circle with a line in the middle, represents an angle. Angle that's unknown. So that's our variable that we use for angles when we're using radians. So if theta is a central angle in a circle with a radius r, then the length of the intercepted arc s is given by s equals r theta. That is it. That's it. It's really important though that theta is measured in radians. Otherwise, you would still use that. So maybe looking at this, you can tell where the 2 pi r 360 comes from. See how that relates to the theta and the radians, but I digress. So we want to find the length of the intercepted arc given by the angle measure and its radius. So I'll keep that formula up there for you. So S is the arc length I'm looking for. That equals the radius times, we want to keep it in terms of pi, times pi over 6. So this doesn't reduce at all, so that I would just keep that as 13 pi over 6. Can't reduce that. Inches. Boom. Done. A little bit easier when that's given in radians, right? So that's S that we're looking for right there. Okay, now here, S equals R, the radius, is 16 times theta, 3 pi over 2. So I can reduce that. 8. 8 times 3, 24. 24 pi feet. So that would be like how it's bolded there. Here, this is just a quarter of the circle. So S equals R, radius, times theta, pi over 2, 7, 1. So S equals 7 pi centimeter. It's the last one of its kind with a visual. S equals R theta. All right, nothing to reduce. So I'll just multiply across. So that's 39 pi over 4 feet. So this is theta and R, theta and R. So S equals 3 times 5 pi over 6, 1 and 2. So that gives me 5 pi over 2 feet. Just work with formulas, plugging it in, see what you get out. S equals 14.5 times pi over 4. So that'll give us 14.5 pi over 4. But we don't love a decimal, so I know that I can multiply this by 2 to get a whole number in the numerator. So 29 pi over 8 inches. All right, let's see what we get here. So use the diagram below for these last 3 questions. So we see here that we have an angle in degrees, and we have a radius measured in feet. So calculate the arc length using the formula L equals x over 360 times the circumference. So that's 2 times pi times 11. All right, let's plug it in. Times. So 315 divided by 360, 0.75 times 22. So that'll be 19.25 pi, or 60.5 feet. Sorry, that's also feet. All right, so here I kept pi in, and here I multiplied by the pi. Convert the angle measured to radians. So 315 times, that's where I have to figure where's the 180 and where's the pi go. So since I want this in radians, I'll keep the pi on the top, 180 on the bottom. So 315 pi over 180. Reduce that, 315 over 180. That's 7 pi over 4. Calculate the arc length using S equals R 11 theta 7 pi over 4. So that's going to be 77 pi over 4. Interesting. If I divide that out, I get 60.5 feet. That's what I had there. It's almost as if the formulas are equivalent, which they are. So that was fun. I hope you enjoyed. Please remember to like and subscribe. Anyway, so here's your homework attached. Same thing we did. No surprises. Same idea. Do your homework, do it by yourself, upload it, ask questions if you need to. Take care. Have a great day.